Now we start some extra special problems. Already two special cases are already discussed in our last video. Now we start another special case, SC3. Find the points on the curve y is equal to Find the points on the curve y is equal to 1 by x minus 1 at which slope of the tangent is minus 1. At which slope of the tangent is minus 1. Find the points on the curve y equal to 1 by x minus 1 at which slope of the tangent is minus 1. That means y is equal to y is equal to 1 by x minus 1 is a curve. A tangent is passing through a particular point. Suppose we take x1, y1. We find the point x1, y1. For finding this point, slope of this tangent is already given, minus 1. Now we find the slope of this tangent using this curve. Curve use ചെയ്ത് tangent in the slope കൊടുക്കുക. ആ slope given slope indicate ചെയ്യുമ്പോൾ നമുക്ക് ആ required point കിട്ടും. First of all, we suppose point on the curve is equal to x1 comma y1. Now we find dy by dx is equal to, the derivative of 1 by x is minus 1 by s square and derivative of 1 by x minus 1 is minus 1 divided by x minus 1 the whole square. Now the slope means dy by dx at x1 y1 is equal to minus 1 divided by x1 minus 1 the whole square. It's the slope of this tangent. Now given slope is, given slope is minus 1. These two slopes are same because real tangent base slopes are same line slope in already minus 1 is given. Also this curve you see the slope that is minus 1 by x1 minus 1 the whole square. Here these two slopes are equal, that is minus 1 divided by x1 minus 1 the whole square is equal to minus 1. Here minus cancel, reciprocal, you take in reciprocal, we get answer x1 minus 1 the whole square equal to 1 by 1 is 1. And therefore x1 minus 1 is equal to square root of 1 is plus or minus 1. Therefore we get two values for x1, that is x1 is equal to x1 minus 1 is equal to plus 1, that is 1 plus 1 is equal to answer is 2. Second is x1 is equal to minus 1 plus 1 is equal to 0. And therefore the corresponding y coordinate, for finding y coordinate, you already know x1 y1 is a point which is common to this curve and tangent also. x1 y1 already satisfy the given curve. Now y1 is equal to 1 divided by x1 minus 1. Therefore when x1 is equal to y1 is equal to 1 by 2 minus 1. 2 minus 1 is 1 by 1 is 1. And x1 is equal to 0, therefore y1 is equal to 1 by 0 minus 1, that is 1 by minus 1, 1 by 0 minus 1 is 1 by minus 1, his answer is minus 1. And therefore the required points are, x coordinate is 2 and therefore corresponding y coordinate is 1, and the second is 0 minus 1. That's all. Okay, the question is find the points on the curve y equal to 1 by x minus 1 at which slope of that tangent to that curve is minus 1. Okay, touching the x and coordinate touch the tangent, the slope is already given. Now we find the slope of the tangent using this curve. Curve differentiate x and pass we get the slope of this tangent, that is minus 1 by x1 minus 1 the whole square, which is equal to the given slope minus 1. And therefore x1 is equal to we get times two values plus 1 and minus 1. x1 is equal to we get 2 and 0. 2 and 0 given curve substitute about we get y1 is equal to 1 and minus 1. Therefore the required points are 2 1 and 0 minus 1. So it's very important question. Now SC4. For the curve y is equal to 4x cube minus 2x raised to 5, y is equal to 4x cube minus 4x cube minus 2x raised to 5, at which find all the points at which tangent pass through the origin. For the curve y is equal to 4x cube minus 2x raised to 5, find all the points at which tangent passes through the origin. Tangent pass through the origin. If you have any doubt in the question, please refer 6.3 exercise, question number 18. Question number 18. Our question is, for the curve y equal to 4x cube minus 2x raised to 5, find all the points at which tangent pass through the origin. So 50 degree curve is a 50 degree curve. ഒന്നിലധികം ടേണിംഗുകൾ ഉണ്ടാവും. സപ്പോസ് ഒരു പർട്ടിക്കുലർ പോയിന്റ് വഴി ഒരു ടാൻജന്റ് ലൈൻ പാസ് ചെയ്യുന്നു. സപ്പോസ് ലൈൻ ഈസ് പാസിംഗ് ത്രൂ this curve. Okay, tangent line is passing through the curve. Also this tangent is passed through the origin. This tangent is passed through the origin. Okay, this tangent line is passed through the origin. Okay, now we find the touching point. We find the point of contact, that is, suppose you take x1 again. Suppose you take that point. Suppose the point on the curve is x1, y1. How you find x1, y1? How to find the x1, y1? First of all, we find the slope of this tangent line. Finding slope, first we find derivative of the given function. That is 4 into x cube derivative 3x square minus 2 into x raised to 5 derivative 5x raised to 4 is equal to 12x square minus 10x raised to 4. Okay. Now the slope. Here slope is equal to dy by dx. Here the touching point is x1, y1, pass here, and therefore we get answer 12x1 square minus 10x1 raised to 4. Here given tangent passes through the origin. You know, the tangent is passed through the origin. But suppose we want to pass this point, I mean 0, 0 pass. First of all, we find the equation of this tangent. We find the equation of tangent. Next we find equation of tangent. Equation of tangent. Here the point is x1, y1. Therefore, y minus y1 is equal to dy by dx at x1, y1 into x minus x1. That is, y minus y1 is equal to, you know, dy at x1, y1 is 12x1 square minus 10x1 raised to 4 into x minus x1, which is the equation of tangent, equation number 1. Here this point, the required point is, we take x1, y1. Next we find slope of this tangent. Using this slope, we find equation of tangent. Equation of tangent in terms of x1, y1 lana. x1, y1 lana. Okay. Now, we are given this tangent line passes through the origin. That is, here our equation of tangent is y minus y1 is equal to 12x1 square minus 10x1 raised to 4 into x minus x1. Here given equation 1, which is the equation of tangent. Equation 1 passing through the origin. Origin means 0, 0. That means here we put x is equal to 0 and y equal to 0, because here x and y1 is a fixed point. So here now we passing through this variable point x y as 0, 0. That is, when y equal to 0, therefore we get answer minus y1 is equal to 12x1 square minus 10x1 raised to 4 into 0 minus x1, that is minus x1. Minus minus cancel, and therefore y1 is equal to, when multiply x1 each time, therefore 12x1 cube minus 10x1 raised to 5. Okay, we get answer y1 is equal to 12x1 cube minus 10x1 raised to 5. You already know our curve passing through x1, y1 also. Our equation of the curve is y is equal to 4x cube minus 2x raised to 5. This curve is passed through x and y1. That means x and y1 satisfy this curve. Our equation is y1 is equal to 4x cube minus 2x raised to 5. Because our curve and tangent is passing through that common point x and y. When x and y pass through this curve, we get answer y1 is equal to 4x cube minus 2x raised to 5. Now we substitute the y1 to the equation, and therefore what is y? y1 is 4x1 cube minus 2x raised to 5 is equal to 12x cube minus 10x raised to 5. Now we collect the terms on the left side, therefore 4x1 cube minus 12x1 cube minus 2x raised to 5 plus minus 10x raised to 5 left side plus 10x raised to 5 is equal to 0. Now adding this term we get answer 4 minus 12 is minus 8x cube minus 2x raised to 5 plus 10x raised to 5 plus 8x raised to 5 is equal to 0. That implies here the common term is 8 and x1 cube is common. Balance minus 1 plus when x1 cube is common we get answer x1 square is equal to 0. Now here the two factors product is 0. And either using 0 factorization theorem, either 8x1 cube equal to 0 or minus 1 plus x1 square is equal to 0. Therefore x1 is equal to we get answer 0 and x1 square is equal to plus 1. That implies x1 is equal to we get answer plus or minus 1. Now what is y1? y1 corresponding to the function is 4x1 cube minus 2x raised to 5. When x1 is equal to 0, we get answer y1 is equal to 0. Then x1 is equal to plus 1 and therefore y1 is equal to 4 minus 2 is equal to 2. When x1 is equal to minus 1, therefore y1 is minus 4 plus 2 is equal to minus 2. Therefore, the required points are 0, 0 is already given. But we answer it 0, 0. Then second is 1, 2. And third point is minus 1, minus 2. That's all. It's a very important question. Try to understand the concept and then find the points. Here, first of all, you select the required points as x1, y1. Now find the slope of the tangent to the curve. First of all, we find the slope of this tangent. For finding the slope of the tangent, first we find the derivative of this function. We get answer 12x square minus 10x raised to 4. Now we substitute x and y1, we get slope of this tangent. Using that slope, we find the equation of tangent because here given tangent line is passed through the origin. So first we find the equation of the tangent. Equation of tangent is y minus y1 is equal to dy by dx at x and y1 into x minus x1. Here y1 is x and y1, there is no change, but dy by dx at x and we get answer 12x square minus 10x raised to 4. Now pass through the point x and y1, we get answer y1 minus y1 is equal to 12x square minus 10x raised to 4 into x minus x, and then pass through the origin. Therefore 0 minus y1 is equal to, here xy is a variable, so we pass through the origin through the variable xy. Therefore minus y1 equal to 12x square minus 10x raised to 4 into 0 minus x1. Minus minus cancel, and therefore y1 equal to 12x cube minus 10x raised to 5. Here you already know x and y1 is a point which is common to this tangent, the curve also. Here automatically x and y1 satisfy the given curve, and therefore our equation is y1 is equal, our curve changes to y1 is equal to, when x and y1 satisfy the curve, which is the equation, the given curve. When x and y1 pass through this curve, we get answer y1 equal to 4x cube minus 2x raised to 5. Now we substitute the value to the left side, we get answer 4x cube minus 2x raised to 5 is equal to 12x cube minus 10x raised to 5. Now collect the terms on the left side and group the term. Then we take the 8x cube as a factor, then equating to 0 by using 0 factorization theorem, we get x1 is equal to 3 values 0, 1 and minus 1. Now we substitute x 0, 1 and minus 1 to the given function. That is y1 equal to 4x cube minus 2x raised to 4. We substitute x1 equal to 0, y1 equal to 0. When x1 equal to 1, y equal to 2. y1 equal to 2 and x1 equal to minus 1, we get to y1 is equal to minus 2. Therefore, the required points are 0, 0, 1, 2 and minus 1, minus 2. Now, we discuss special case 5. Special case 5. Before discussing special case 5, we form a new idea about application. That is, a function y is equal to f of x. A function y is equal to f of x. Suppose the function y is equal to f of x. A tangent is formed through this point. That tangent is parallel to x-axis. Suppose we consider another function y is equal to f of x. Suppose here the tangent is perpendicular to x-axis. Okay. When a tangent is parallel to x-axis, then here theta is equal to 0. That means slope m is equal to 0. If suppose the touching point is x1, y1, and tangent, our first condition, tangent parallel to x-axis, then slope, you know, the slope tan theta is also equal to dy by dx at x1, y1 is equal to 0, which is the main condition. Where tangent line is parallel to x-axis, then dy by dx at x1, y1 equal to 0. Then second condition is, if tangent is perpendicular to x-axis, then theta equal to 90 degree. That if tan theta is equal to tan 90 is not defined, that is 1 by 0, infinity, tan 90 is equal to 1 by 0, and therefore is reciprocally 0 by 1 is 0. And therefore here, when a tangent is perpendicular to x-axis, then the condition is reciprocal, that is dx by dy at x1, y1 is equal to 0. These two conditions are very important. If a tangent is parallel to x-axis, then dy by dx at x1, y1 equal to 0. If a tangent is parallel to x-axis, then dy by dx at x1, y1 is equal to 0. If a tangent is perpendicular to x-axis, then dx by dy at x1, y1 equal to 0. It's a very important condition. Using this condition, we form special case 5. We find the special case 5. Okay. Now, SC5. Find the points on the curve. Find the points on the curve s square by 16 plus y square by 9 is equal to 1. Find the points on the curve s square by 16 plus y square by 9 is equal to 1, at which our first question is tangent parallel to x-axis, tangent parallel to x-axis, and second is tangent perpendicular to x-axis, tangent is perpendicular to x-axis. That's all. And the points on the curve s square by 16 plus y square by 9 is equal to 1, at which tangent parallel to x-axis, and second question is tangent perpendicular to x-axis. Actually, s square by square by 16 plus y square by 9 is equal to 1. Square by 16 plus y square by 9 is equal to 1 means here the tangent intersect the x-axis at a 4, 0 and minus 4, 0. Y-axis at 0, 3 and 0, minus 3. Okay. Here tangent is parallel to x-axis. That means the tangent parallel to x-axis means these two tangent parallel to x-axis. That means the tangent is parallel to x-axis through the point 0, 3 and 0, minus 3, and the tangent perpendicular to x-axis means this tangent is perpendicular through this point. That means this tangent is perpendicular at the 4, 0 and minus 4, 0. Okay. But here we find the these points using derivatives. So actual concept is this. The derivative use in the points. Okay. Here first of all we consider the points on the curve is equal to x1, y1. Here the given curve is x square by 16 plus y square by 9 is equal to 1. Now differentiating with respect to x, we get answer 2x divided by 16 plus 2y divided by 9 into y derivative is dy by dx because it's an implicit function and derivative 1 becomes 0. Therefore, 2y divided by 9 into dy by dx is equal to minus 2x divided by 16. Therefore, dy by dx is equal to, on cross multiplying here 2 to cancel, and therefore minus 9x divided by 16y. Now the slope of the tangent is dy by dx at x1 y1 because the touching point is we consider as x1 y1, and therefore we get answer minus 9x1 divided by 16y1, which is the slope of the tangent. Now the first question. Since the tangent parallel to x-axis, since the tangent is parallel to x-axis, then the condition is dy by dx, that is slope of the tangent is 0. dy by dx at x and y1 equal to 0. That means minus 9x1 divided by 16y1 is equal to 0. On cross multiplying this time, we get answer minus 9x1 is equal to 0, and therefore x1 is equal to 0 divided by minus 9, answer is 0. x1 y1 is a point, but tangent of these 2 points is a possibility. x1 y1 is a point which is common to tangent and curve also. So actually x1 y1 satisfy the curve also. When x1 y1 pass through this curve, that is, we get answer x1 square by 16 plus y1 square by 9 is equal to 1. Now we put x1 is equal to 0, and therefore we get answer 0 plus y1 square by 9 is equal to 1. If y1 square is equal to 9, that implies y1 is equal to, we get answer plus or minus 3, and therefore the required points are that point, the point tangent pass through this point that is parallel to x-axis. The required points are x1 equal to 0, y equal to 3, and x1 is equal to 0, y1 is equal to minus 3. Clearly, already we get tangent pass through the points are 0, 3 and 0, minus 3. Okay, next we find when a tangent perpendicular to x-axis. ഏതൊക്കെ പോയിന്റ് വഴിയാണ് ടാൻജന്റ് x-axis perpendicular ആയിട്ട് പോകുന്നത്? When a tangent perpendicular to the x-axis, tangent perpendicular to the x-axis, then the condition is dx by dy at x1 y1 is equal to 0. dy by dx at x1 y1 is answer is minus 9x1 divided by 16y1. Therefore dx by dy means reciprocal, that is 16 y1 divided by minus 9x1 is equal to 0. On cross multiplying time, therefore 16 y1 is equal to 0. Therefore y1 equal to 0 divided by 16, 0. You already know x1 y1 is a point on the ellipse also. When x1 y1 pass through the ellipse, we get answer x1 square by 16 plus y1 square by 9 is equal to 1. Now we put y1 equal to 0, and therefore x1 square by 16 plus 0 is equal to 1, and therefore x1 square is equal to 16. That implies x1 is equal to plus or minus 4, and therefore the required points are 4, 0 and minus 4, 0. ഈ രണ്ട് പോയിന്റ് വഴി കിടന്ന ടാൻജന്റ് ലൈൻ x-axis perpendicular. 0, 3 and 0 minus 3 കിടന്നു പോകുന്ന ടാൻജന്റ് ലൈൻ x-axis parallel. That's all. Okay. Okay, next I will one more question, which is where we use the condition for parallel. Now next question is, find the points on the curve. Find the points on the curve. That is 6.3 exercise, question number 19. Find the points on the curve. X square plus y square. X square plus y square minus 2x minus 3 equal to 0. Find the points on the curve x square plus y square minus 2x minus 3 equal to 0, at which the tangent parallel to x-axis, at which the tangent parallel to x-axis. It's a circle. It's a circle. Okay. First of all, we suppose the required point as x1 y1. Suppose x1 y1. The point is x1 y1. The point is x1 y1. Then we find slope. That is x square plus y square minus 2x minus 3 equal to 0. Now differentiating, we get answer x square derivative x, y square derivative y, and derivative y with respect to x dy by dx minus 2 into 1 minus 0 equal to 0. Therefore 2y into dy by dx is equal to 2 minus 2x. Therefore dy by dx is equal to 2 minus 2x divided by 2y. 2 cancel here. Therefore we get answer 1 minus x divided by y. Now the slope. For finding slope, we pass x1 y1 through this derivative. And x1 y1 pass here, we get answer 1 minus x1 divided by y1. Now the condition. The tangent is parallel to x-axis. Since tangent parallel to x-axis, therefore the condition is dy by dx at x1 y1 is equal to 0. That is 1 minus x1 divided by y1. That is 1 minus x1 divided by y1 is equal to 0. And therefore 1 minus x1 is equal to 0. Minus x1 is equal to minus 1. x1 is equal to, we get answer 1. x1 y1 is a point on the curve also. Therefore automatically x1 y1 satisfies the given curve. That is, here x1 square plus y1 square minus 2x1 minus 3 is equal to 0. When we put x1 equal to 1, we get answer 1 plus y1 square minus 2 minus 3 is equal to 0. And therefore y1 square is equal to minus 5 plus 1, that is minus 4 equal to plus 4. And therefore y1 is equal to, we get answer plus or minus 2. Therefore the required points are 1, 2 and 1 minus 2. That's all. Okay. Our next video we will discuss our next topic, increasing and decreasing function. Bye.